Hello, good evening. All right. Before we start the class, can you help me to like my YouTube? Press the like button. Thank you. And then we are going to start Form 4, Chapter 2. All right. This Chapter 2, it is quite long chapter. So we quickly go to what is linear motion. Okay. So linear means straight line. So the object is moving in a straight line. Motion mean movement. So now first thing that you need to know is what is distance and what is displacement. What is the difference? So previously we have learned it is scalar quantity. It has magnitude only, no direction for distance. But displacement has both magnitude and direction, so it is a vector quantity. So we go into detail. What is distance? What is displacement? So a boy, he start to move forward 20 meter and then go back 5 meter. So go 20 and then go back 5. So now find the total distance move. Distance, so sometimes we can use D, right? The symbol of D. D, it is 20 plus 5. So it has no direction. No direction. So you need to plus all. Right? 20 plus 5. So answer is 25 meter. Now, how about what is displacement? All right. So displacement has direction one. Displacement has both magnitude and direction. So direction means it has positive and negative. It can be left hand side, can be right hand side. So now, so displacement, we are going to see how are we going to do it. Okay, now you you open your eye, you see I am here. So after you cross your eye already, you open your eye and then you close your eye. You cannot see how I move. Cannot see. Don't open your eye. All right, stop. No, okay, open your eye again. So I am here. So you don't know that I am moving here to here. You don't know. You just know you are here. I am here, and then I move to here. Right? So this is your displacement. Your displacement is 20 minus 5. So it is your displacement, it is 15 meter. Okay? So where it start and where it stop only. So displacement, the symbol of displacement is S. Alright, small s, not capital letter. It is small. Alright. So 20 minus 5. So it is 15 meter. The unit of distance and displacement, it is the same. Both are meter. Okay. Now we look at example number 2. So a boy moved to here, 20 meter, and then move 20 meter, and then move back 10 meter. So a boy move forward 20 meter and return back to the original point, and then go backward for 10 meter again. So find the total distance move. Alright, so distance no direction. So distance no direction. You just plus them up. So 20 plus 20 plus 10. So answer is 50 meter. Now, how about displacement? Displacement is where do you start and where do you stop. Alright, so where do you start to where do you stop? So displacement is, so you move from here to here, it is 10 meter. Wrong. What's wrong? Displacement has direction. So you need to know, right? Where you start, you cross your eye, and then finally I move to here and then I stop here. Teacher, you move 10 meter. Yeah? 10 meter? No. So this one tell you 10 meter where? Left hand side or right hand side? If positive 10, it is right hand side. So like this 15, it is right hand side. So if it is left hand side, so we are going to take it as negative 10. Right? So this negative tell you the direction where it is. Alright, left hand side or right hand side. Okay. So this is about what is distance and displacement. Now, some of you will ask me, Cikgu, the distance and displacement, are they the same thing? So if you are here, you move 10 meter, right? You are here, then you stop at here, right? 10 meter. What is your distance? 10 meter. Your displacement? 10 meter, right? Is it the same? Yes, right? If you move another 10 more meter here, right? So what is your distance? Distance is 20 meter, I'm sorry. Displacement also 20 meter. So distance and displacement, it is the same if you don't turn back. If you don't change your direction, you just move forward only. So distance and displacement will be the same. Alright. So if you turn back, then distance and displacement will be different. Alright, you need to know this. Now, second thing, it is about speed and velocity. What is speed? Alright, so speed is, the formula is, speed is distance over time. Distance divided by time. So when you see the divided by time, so when you put it into words, so it will be rate. Rate. Change mean minus. Change mean minus. Rate of change in distance mean initial distance minus final distance over the time. Alright. Rate divided by time, it is rate of change in distance. So initial you are 0. Alright. Final you minus. Okay. So this is speed. Now, speed, what is the symbol that we use? We don't use any symbol for speed. We don't use it. But the definition you need to memorize. So, rate of change in distance. Alright. So, what is velocity? Velocity is displacement divided by time. Displacement divided by time. So, divided by time, we call it as rate. Rate of change in displacement. Rate of change in displacement. So, now we are going to see this example. A boy move forward for 20 meter and move backward for 5. Move 20 and move back 5 in 10 seconds. Find speed. Speed is equals to rate of change in distance. So distance divided by time. Normally, I am not going to write this, but this is the first time, so we don't write it. So I'll write D over T. Right? Big capital letter D over small t. Alright, so rate of change in distance. So now, what is the distance that you have moved? You have moved 20 and then you move back 5. You move 20, you can see how I move. You move 20, you move 5. So 20 plus 5. So 20 plus 5 divided by time. Time is 10 seconds. So 25 divided by 10, it is 2.5. It is 2.5. What is the unit of speed? Speed, this one will be in meter. Alright. This one will be in second. So meter divided second, we write ms minus 1. Ms minus 1. Okay, now of course you will ask me, Cikgu, this one I need to write meter here or not? Up to you. You want, then okay, go ahead. You want to put second here? Yeah. Right. During the substitution, you can no need to put the unit, but answer must put the unit. Answer must put. Right. During the substitution, you can no need to put. Right. Up to you. You want, also can. Right. Nothing wrong. Okay. We'll find speed. Right. Speed. So second one, find the velocity. So velocity is displacement over time. Right? Velocity. So velocity, the symbol that we use is v. Right? Small v is equal to displacement divided by time. Divided by time. So how much is the displacement? So how much is the displacement? So where do you start? Here to where do you stop? You cross your eye and then I move and then you open your eye again. So this one to here, it is 15. So it is 20 minus 5. Just now we had done it. Right? 20 minus 5 over the time taken. Time taken, it is 10 seconds. So 15 divided by 10, it is 1.5. So it is 1.5. Unit is ms minus 1. Okay. Now, are you okay with here? Now, if I move from here, let's say I move from here 20 meter and then I move back in 10 seconds. So your speed will be equivalent to how much? Right? 20 plus 20 divided by time 10 seconds. So 40 divided by 10, it is 4 ms minus 1. But velocity, so velocity is where you start, you open your eye and then close your eye, cannot see how I move. Now you go back to original point. So you don't move, alright? This one is 0 over 10. So your velocity, it is 0. Your speed is for 4, but your velocity is 0. Right? So that's the difference between speed and velocity. Right? You need to differentiate them. Is that okay? Alright. So we are going to see this example. Example number 4. So a boy moved from a point A to C in 10 minutes. Alright. So point A to B to C in 10 minutes. So find the speed. So we know what is the speed. Speed is distance over time. Alright. As I told you, I am going to use d over t. Right? D is distance. T is time. Distance over time. So how much is the distance here? Distance is you have to plus them up. Alright. So you plus 6,000. 6 km is 6,000. And then add 1,000. 6,000 plus 8,000 meter. Divided by time. 10 minutes. So you cannot use minute. Change it to second. Alright. So 10 times 60. So this is your speed. Right. So you 14,000 divided by 600. 14,000 divided by 600. So how much will I get? 23.33. ms minus 1. The unit is ms minus 1. Alright. I hope you're okay. So second one, we are going to find velocity. Velocity, the symbol is V. V is displacement over time. Displacement is S. Time is T. Alright. So we are going to find velocity. How much? So velocity is displacement. So we check how much is displacement. Alright. So where do you start? Okay, A. So close your eye. Don't see how I move. Cannot see how I move. And then finally I am at here. Alright. Open your eye. I'm at here. So you need to take the distance of here to here. Here to here. Right, here to here. So you have learned in from lower form 6 at 10. Alright, so this one is 10 km. Right, so this one is 10,000. Right, Pythagoras theorem. Alright, so time is 10 minutes, 10 times 60. Okay, so 10,000 divided by 600. So we'll get 16.67. So you get 16.67 as the velocity. ms minus 1. The unit. Okay. Now, most of the time, the question will say, oh, where is the direction? So velocity, because of it has direction. So you need to say it is to north, to south, to east, to west, to north-south, to northeast, to northwest. Sometimes they'll come into this way. But normally, no. They will ask you how much is the value of the velocity only. You just write the number in. But if the question asks, then you need to put. You need to tell them where is the direction. Now, in case you want to know, this is this is east, this is west. No, this is north. Sorry, this is north, south, east, and west. Right. So now into this direction, it is northeast. The direction is northeast. Right, into this direction, northeast. Okay, north. So how do I memorize? Most of you don't your geography, you don't learn this, or you learn in BM, so you are not really sure, teacher, where is north, where is south, where is, so where's Malaysia, right? Our Malaysia like that, okay? Malaysia like that. So this is Sima, right? West Malaysia. This is Dongma, right? East Malaysia, right? So north always point to the north. So this one is always point to the north, south. Okay. All right. So we have learned what is speed, what is velocity already. So we are going to see A. Alright. So what is A? A is acceleration. So acceleration is positive, we call it acceleration. If negative, we are going to call it as deceleration. Right? Deceleration. So the formula is A is V minus U over T. What is V? What is U? Right? So V is final velocity. Final velocity. U is initial velocity. T is time. Right? And the final and initial, so you follow the alphabet 1 A B C D E F G H I J K L M N O P Q R S T T U V. U first. U is initial. V is final. U V. Alright. After U, then it is V. So this one is initial, starting. What is the velocity? And then this is your final velocity. Alright. So now A is V minus U over T is our formula. So the definition of the acceleration is divided by time. Divided by time, we call it rate. Rate of change in the in velocity. Rate of change in velocity. If you want the definition, rate of change in velocity. So we look at some example. A car start to move from rest, and I put it to here. A car start to move from rest and to a velocity 25 in 5 seconds. Find the acceleration of the car. So now you have to see the unit. Right? Look at the unit. Right? This is 25 ms minus 1. When you see ms minus 1, you know it is velocity. This one is velocity. Right? So this is 5 seconds. 5 seconds. So it is time. You know it is time. So this velocity is final or initial. So you need to identify them. Alright. So now there is some hidden information here, which is race. So a car start to move from rest. At first you are at rest. At first you are not moving. You're not moving. The car is not moving. And then it to 25. So starting, the velocity is 0. Final velocity is 25. So you need to know. So now in the future, never mind, I put it to here first. In the future, I will teach you into detail when I teach the formula here about the keyword here. Wait, let me find wait, it's for formula here. Wait, 1 minute. Linear motion graph. After linear motion graph, it is no. Here. Okay. Okay, I copy it here and put it to here for you. Okay, so when you start to move, the initial velocity is 0. U is 0. From rest, U is 0. Drop, U is 0. Stationary, from stationary, U is 0. Right? Stop, you move, and then you stop. After you stop, then you know don't move. Don't move means the final velocity is 0. Maximum height, so final velocity is 0. Now this one, in the future, I'll teach you into detail. Right now, you just need to know start to move or from rest. Start to move or from rest, U is 0. Okay, so this one. So we are going to put it in. So what is the formula? A is equal to V minus U over T. V minus U divided by T. V is final. U is initial. T is time. A is acceleration. So now start to move, right? Okay, start to move. So final is 25 minus initial from rest, it is 0. Over the time taken, it is 5. Okay, now 25 minus 0, 25, 25 divided 5, 5. The answer is 5. Unit is ms negative 2. Why ms negative 2? The unit. Okay, let me explain to you. So why the unit is ms negative 2? What is the unit of velocity? Velocity is ms negative 1. Time 5 second. So ms negative 1 minus 1. So altogether is minus 2. Ms negative 2. So this is ms negative 2. Unit of acceleration. Now, of course, you will ask me, teacher, what is minus? So minus will not change the unit. Minus will not change the unit. For example, like only divide or time will change the unit, right? So for example, like at Rm10 minus Rm2. So what is the unit? So your unit is Rm8. Your Rm10 minus Rm2 is still Rm8, still Rm. But your Rm10 divide Rm2, so you cancel your Rm. So it is 5%. Divide will cancel the unit, right? So plus minus will not change the unit here. Your unit will not change. Okay. So this is answer is 5 ms negative 2. So car slow down for 30 and then stop in front of the traffic light in 5 seconds. Find the deceleration of the car. So formula is A is equal to V minus U over T. Not capital letter, it is small t. So I better copy this letter. I need to use for many times. So final velocity. So you need to see this unit is 30 ms negative 1. So this is velocity, I know. This one is 5 seconds. This is time, I know. And then stop. The car is moving 30. And then suddenly he pressed the brake and then slow down. Stop. Okay, so initial starting, what is the velocity? Starting it is 30. Final it is stop. Final stop. Final stop. Alright. Stop. The final velocity is 0. Okay, 0 minus initial it is 30. Over the time taken 5. So 5. So negative 30 divided 5. So you get negative 6. Okay, the unit is ms negative 2. But the question asking you, find the deceleration. So we know how much is the acceleration. The acceleration is negative 6. Acceleration is negative 6. So the deceleration will be 6. Deceleration will be 6. So you need to rewrite this. We don't have any formula for deceleration. But we know that negative of the acceleration is deceleration. What is deceleration? So acceleration, the sound look like woo. Deceleration, the sound like woo. Stop. Slow down. Right? So decrease in acceleration. Deceleration. Okay? Deceleration is 6. Alright, are you okay with this? Are you okay with this? So I hope you're okay. Alright. We continue. A train slow down from 70 and then decelerate for 2 ms negative 2 in 10 seconds. Find the final velocity of the train. So now formula is A is equal to V minus U of T. Alright, we are going to put it in. So A. So I don't know. Right? A is 2. A is 2. right? So slow down from 70, final velocity, and then uh, what is find the final velocity? Final velocity, I don't know, but this one is velocity. So slow down from 70, So your starting is 70, right? So over the time is 10 seconds. So now this question, I purposely do it wrongly. The answer is wrong if I do it this way. And then I still continue to do it. So 2 times 10 is 20. 20 plus 70. So my final velocity is 90. Okay. So what's wrong? Why I get my... 90. What am I doing? 10, 20 plus 70, 90. So 90. Okay. 2 times 10 is 20. Negative 70 come to here become plus. Right? So 70 plus 20, I got 90. So what's wrong? What's wrong? Where do I get wrong? Where do I get wrong? So now you try to understand it. So a train slow down from 70. So your starting is 70, the velocity is 70. So getting slower. But you said your final velocity become 90. How can it be? So if you start from 70, you want to go to 90, so your velocity should be increased, right? So this one is deceleration of 2. Deceleration of 2. Where do I get wrong? This one is acceleration. Where do I get wrong? Where do I get wrong? Where do I get wrong? So this one should be negative 2. Alright? So negative 2 times 10, negative 20. Negative 20 plus 70. This 70, negative 70 come to here become plus. Left V alone. So I'll get 50. So answer 50 is the correct one. Do you understand it? So this negative tell you this is a deceleration of 2. Right? Is that okay? When you do the question, you have to be very, very careful about this. Right? Is that okay? I hope you're okay. I hope you're okay. Alright. So a car moves with the velocity of 5, start to accelerate with constant acceleration of 3 for 4 seconds. So find the final velocity of the car. So formula A is V minus U over T. So a car moves with a velocity 5 and start to accelerate with constant acceleration of 3. Acceleration is 3 for 4 seconds. 4 seconds. So final velocity, I don't know. So initial velocity, it is 5. I repeat. So I am driving a car with 5. Ooh, suddenly got one car overtake me. I am not happy. I feel like want to chase him. So I start to accelerate. So my acceleration is 3. Ooh, after 10 seconds. After 4 seconds. So how fast am I? At first I'm 5. Final velocity should be increased, right? Because I am accelerating. Right? So acceleration, you look at the unit. Unit is ms negative 2 is acceleration. Right? So 4 seconds, it is time. This is velocity. Ms minus 1 is velocity. You look at the unit. Okay? It will help you. It help you in the unit. The unit will help you a lot. So 4 times 3, 12. 12 plus 5, 17. So V is equal to 17. Unit is ms negative 1. Okay. Now we continue. Driving test. In a driving test, so a car accelerate uniform from rest to 30 in 15 seconds. What is the acceleration of the car? So A is equal to V minus U over T. A is V minus U over T. A Acceleration, don't know. The question said don't know. Right? V, final velocity. Final velocity from rest. Initial is 0. Final is 30. ms minus 1, it is velocity. So final is 30, initial is 0. Right? Over the time taken. How long time? 15 seconds. So 30 divided 15, answer is 2. Unit is ms negative 2. Okay. Alright. Jay is driving his car with 40 and he brakes. So he drives 40. Suddenly he brakes his car. Stop in 20 seconds. Alright. So now find the acceleration. So acceleration. So A is equal to V minus U of T. Alright. So acceleration I don't know. The question asking me. So V, final velocity. You are driving 40 right now and then stop. Final stop. So this stop is telling you final velocity is 0. Right? This one is initial velocity. This is final velocity. Final velocity is 0 minus initial is 40 over the time taken. How long time? In 20 seconds. 20 seconds. So negative 40 divided by 20, answer is negative 2. ms negative 2. Okay. So how much is the acceleration? Negative 2. So if I ask you, how much is the deceleration? So you no need to redo, alright? You just tell me deceleration is equals to 2. That's all. Alright, that's all. You just tell me deceleration is 2. Okay? So how much is the acceleration? Negative 2. Negative 2 means you're slowing down. Ooh. Okay? Is that okay for you? So Najib moving his car from stationary with the acceleration of 2. What is the velocity after a second? So how to do it? A is equal to V minus U of T. A is V minus U of T. I don't know. Right. Wait. A is 2. Acceleration, you look at the unit, ms negative 2. So A is 2. Final velocity after at second. So what is velocity at second? I don't know. Right. Start from stationary. Stationary means initially it is not moving. So initial velocity is 0. Final, I don't know. Initial is 0. Over the time at second. Add time it up 16. So V is equals to 16 ms negative 1. Okay. Alright. Is that okay for you? So we continue from here. A rocket is accelerated at 120. Right? If the rocket were resting at the beginning, what is the final velocity after 30 seconds? So I want to tell you this. Now, of course, some of you were like not really sure. Teacher, this is after at second. So after a second mean 9 seconds or 10 seconds also can, right? No. So in physics, we call at after at second is at second. They are the same thing. Right? So not after at, it is like 9, 10. No. Right? So what is the velocity after 30 seconds? Not 31, not 32, 35. No. It is 30 seconds. Okay, you have to take notes of this. So a rocket, it is accelerated at 120 ms negative 2. So this is ms negative 2. So we know the acceleration already. Rocket rests at the beginning. Initial velocity, it is 0. Find the final velocity, right? After 30 seconds. So A is equal to V minus U over T, the formula. A, acceleration, 120. V, Final velocity, don't know. Right. Initial velocity is 0. Why 0? Rest at the beginning. Over the time taken, it is 30 seconds. 30 seconds. So 30 seconds, V minus 0 is V. So 30 time it up. So 120 times 30. So you get 3,600 final velocity. Is that okay? All right. All right. So a car decelerates uniformly from 40 with the deceleration of 5 ms negative 2. Find the initial velocity at 3. Find the time taken for the car to stop. Okay, this is two different questions. So a car decelerates uniformly from 40. So this one is decelerate 40. Teacher, this one is deceleration. No. Why? You look at what is the unit. This unit is ms negative 1. ms negative 1 is velocity, not deceleration. Okay? Not deceleration. So A is equal to V minus UOT at number 1. Now, A, deceleration of 5. This one is a deceleration. Deceleration. So it is negative 5. Right? V minus UOT. V. So this one is U or V. So a car at first it decelerate. So from 40, slow down and stop. Okay? 40. Alright. Initial is 40. I'm sorry. Initial is 40. Final velocity at 3 seconds, I don't know. So you ask me, teacher, final velocity is in it 0. The question not telling me I am stopped. No. Only second question that they said it is stop. So here, not stopping yet. So final velocity at 3 seconds, I don't know. Initial is 40. Over the time taken, 3 seconds. 3 seconds at here. So 3 times 5, 15. Negative 15 plus 40. Negative 15 plus 40. You get 25, right? So the final velocity is 25. Maybe some of you not really sure about this, so I do it too fast. 3 times 5, 15. So negative 15 is equal to V plus 40. Negative 40 come to here become plus. Negative 15 plus 40 is my V. Right? So we are going to write V is 40 minus 15. Negative 15 plus 40. So that's how I come from. Negative 15 plus 40. Negative 15 plus 40. I do it faster. So we get 25. Okay. We get 25. So number 2. Time taken for the car to stop. So you cannot use the information here already. Teacher, the velocity is 25. No. You cannot use here. Cannot use this already. So you have to use here, here, and here. Okay. So number 2. What do we have is they are asking me time taken for the car to stop. So I don't know how long time it takes. So the deceleration still 5. Alright. Deceleration still 5. Still 5. Deceleration is 5. So V minus U. Final velocity. Stop. Final velocity 0. Initial velocity is starting 40. Alright. How long time it take? I don't know. T go up. Alright. So this one is negative 5t. Negative 5t is equal to 0 minus 40. It is 40. So t is negative 5. Negative cancel. So divide. So answer is 8. So now normally I will do it fast. This one go up. This one go down. Negative 40 divided negative 5. So you get 8 seconds. T is equal to 8 seconds. Any question from here? Any question from here? I hope you're okay. Okay. All right. Okay. So we continue to see what is ticker timer and ticker tape. Okay. Now this is ticker timer, ticker tape. So this is in your physics experiment. So you are going to do one experiment. So you got a paper there. So the paper here. So you got one machine here, like here. So this machine is used to tick. So we call it ticker timer. Right. And then this is a tape. Right. This is a paper, ticker tape paper. So you are going to tick it. What is the use? To record the motion, to record the time, to record the velocities, all this. Right? To check how fast do you move, how far do you move, all this information. So now, first of all, now what do you need to do is the frequency of the ticker timer, it is 50 hertz. Why it is 50 hertz? Because it is using alternating current. Alternating current is 50 hertz. So the frequency of the ticker timer will be 50 hertz. You need to know. Now, so 1 divided 50, right? 1 divided 50 mean 1 second I can 50 times. I can do 50 ticks. So 1 divided 50, it is 0.02. So every tick you will give me 0.02 second. Right? This one is fixed. So what is one tick? One tick. So one tick mean here to here it is one tick. Here to here it is called one tick. Not one dot here is one tick. No. This is not called one tick. Here the distance here it is called one tick. Here one tick. Here one tick. Here one tick. Right? So how long time it takes? 0.02 second. Here 0.02 second. Even it is long or short, it is the same. 0.02 second. Alright, this is what we have. Now, the next thing is, now you need to know type of the motion. Right? So if the distance, it is quite all similar, all same length. So meaning that it is constant velocity. So mean the velocity is same all the way. Right? But if the distance of this one is closer, mean it is slow. Right? But this one is the distance still constant, right? Constant velocity. But when this one is long, it is fast. When this one is short, when this one is shorter, you compare these two. Very quite same. You can see this one. So this one is shorter. So it is slow. So what does that mean? Okay, now I want you to understand this. So I take one explanation from here. Let's say you are here. I get a roll of toilet paper here. So this roll of toilet paper is like that. Okay. So now when I start to pull here, so this toilet paper will start to roll. Right? You go rolling, right? So now what you see is here, right? So I got one piece. I take one marker paper, marker pen to tick here, right? To start to draw here, tick. So when you start to pull, so this thing it is going to move, right? I tick here, so this one got a dot, right? Wait. So okay, dot here. Now because of you are pulling it away, you are pulling this piece of paper away. You pull it away. So the next 0.02 second, I'm going to tick again. I'm going to tick again. It is here, right? So after 0.02, you keep on pulling. right? So I am going to keep on ticking. So I will get this one. So if you're pulling it slow, the distance of two tick here, one tick here will be near, like this, near, slow. If this one is far, mean you are moving fast, right? That's all. Okay. So what is this? Teacher, what does this arrow mean? So this arrow telling me where do you pull? Where it is pulling. So I pull from this side. I pull from this side. Okay. So now this one is acceleration. Why it is called acceleration? This one it is slow. This one it is fast. Right? Here it is slow. I write down slow. How about here? Here it is fast. So from slow getting faster. So this one is called acceleration. So here it is fast because it is fast. So here it is slow. Meaning that from fast to slow. So this one is called deceleration. Okay? So the type of the motion you have to know. Now, this is the trolley. So this trolley, the piece of ticker tape, it is here. Alright. So I'm going to tick, 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 tick. So when I release this trolley, it is going down like that. So when it's going down, it is not going to turn back. So your distance and your displacement, it is the same because you are not turning back. Unless you're turning back, then different. So I'm going to tick, 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 tick. So I will get this kind of ticker tape. Alright, this pattern. So we are going to study the pattern. You can know what is the information that you can get from the experiment. For example, the first one. We are going to calculate the first one. Now, example 14. Find the average average speed. So speed, we know the formula. Speed don't have symbol. It is distance over the time. Right? Distance over time. How far do you move? Right? How far is this thing moving? So this one move 20 cm. Over how long time it take? How long time it take? Alright. So this teacher, this question not giving me time. Never mind. We know here is 1 tick, 2 tick, 3 tick, 4 tick, 5 tick. 1 tick is 0.02 seconds. Fixed one. You need to memorize. Right. So you got 1, 2, 3, 4, 5. So you got 5 ticks here. 5 times 0.02 seconds. Okay. So this is what is the unit of here? 20 what? 20 cm. This is second. Letter, your unit is cms minus 1. Okay. But you can change it to m, meter. If you want to change it to meter, you divide by 100. You do it letter also can, no worry. So 20 divided by 5, 20 divided by 5, divided by 0.02. You will get 200. Okay, so you get this 200 cms minus 1. But if you want to change to meter, you move 2 decimal. So you get 2 ms minus 1. Also can, no problem. Is that okay? Alright, this is speed. Okay. Now we come to something that is more complicated. So it is called acceleration. How to calculate the acceleration. So the motion of the trolley is I put it into this side. So this one is slow, this one is fast. Right? So this one is slow, this one is fast. So you know this one is accelerating. How about this one? This one is big, this one is small. Right? So this one is fast, this one is slow. So this one is deceleration. Of course you know, right? That's what I told you. Now, what is the acceleration, the formula? The formula is A is equal to V minus U over T. But before this, you need to have V, you need to have U. Okay. Now, so what I do is I want to calculate U first. U is distance over time, displacement over time. All right, displacement over time. So how much is the displacement at first? It is 0.5 cm, right? Cm. So over the time, time is for this one, it is 0.02 second. 0.5 divided by 0.02. 0.5 divided by 0.02. You will get 25. 25 cms minus 1. cms minus 1. Okay, so this one is the velocity here. How about the final velocity? Final velocity is here. So I want to have V, I need to have U, I need to have T so that I can get the A. Right? So I want to get V right now. V is final velocity. Final velocity is 1.4 cm. Right? Displacement over the time. Displacement over the time. So later I'm not going to write the displacement over time already. I will write 1.4 divided by 0.02. 1.4 divided by 0.02. Right? So 1.4 divided by 0.02 is, you get 700. Right? So not 14, 70 should be. 1.4. 1.4 divided by 0.02. You get, why am my point not in? 1.4 divided by 0.02. 70. Okay, it's supposed to be 70. Okay, so I got V, I got U already. So V, U, then I can find T. I know T, so I can find A. So A is equal to V minus U or T. Final velocity, V. V put it in 70 minus initial velocity, 25, over the time taken. Time taken is, now you need to calculate how many tick. 1, 2, 3, 4, 5, 6 tick. Now, when you calculate acceleration, you need to minus 1 tick. So 6 tick, you use 5 tick only. Why? I will tell you later. Right, now you accept it first. So 70 minus 25 divided by 5 divided by 0.02. This one 0.02. I'm sorry, I write it wrongly. So I get negative 180. Okay. Oh, wait. 70 minus 25 equal divided by 5 divided by 0.02. So I will get 450. 450. 450 cm s minus 1. Right. It is 450 cms minus 1. If I want to change it to meter per second, so I divide by 100. So I got 4.5. Here I will get 4.5. ms negative 1. Negative 2, not negative 1. I'm sorry. Acceleration is ms negative 2, not negative 1. Right, my mistake. Are you okay with here? So, now, of course, you ask me, Chegu, Wait got font so annoying, my font. I got people call me. Okay. Wait. Oh, okay. Why it is why I need to minus one? So one more time. 1, 2, 3, 4, 5, 6 tick. Why I need to minus one tick? So I tell you later, okay? I tell you later. Okay, we try one more before I tell you why it is need to minus one tick. Alright. So if you want to find the deceleration, okay, so this is U, this is V. This is U, this is V. So we are going to find U how much first, right? U is equivalent to initial velocity, right? Is equivalent to this 2.5 divided by time, right? 0.02, right? 2.5 divided by 0.02. 2.5 divided by 0.02, so you will get 125. So 125 ms negative 1. Okay. So you got initial velocity already. So this is final velocity. How do I know which one is initial, which one is final? So you look at the error. You pull from here, this one is initial. Right? This is final. Vertical tab. So this is final. Final is V. V is equals to 0.4 divided by 0.02. 0.4 divided by 0.02, I will get 20. Okay, so I got U, I got V already, so I need to find A. How much is the A? Alright, A is equals to formula. A is equals to V minus U over T. Alright, so how much is A? I don't know. V, I get it from here. V, 20. Oh, this is cm. Sorry. My unit is wrong. Should be cm, not meter. Right. So this is 20 minus 125 over the time taken. Now, the time taken, very, very important. I want you to see this one. 1, 2, 3, 4, 5, 6, 7, 8. Right. So 8, you have to minus 1. Become 7. 7 tick. 7 times 0.02. Right. Okay. This one is wrong. C. Okay. So now what do we have is we press in the calculator, see how much it is. So 20 minus 125 equal negative 105 divided by 7 divided by 0.02. Okay. So you get negative 750. CMS minus 2. Okay. So if you want to change it to meter, so you move 2 decimal, it is equal to 75. So I don't change it here. But I want to tell you why. Teacher, why minus 1? 1, 2, 3, 4, 5, 6, 7, 8. You minus 1 becomes 7. So I make a short note for you here. When you are calculating acceleration, right? Minus 1 tick. When you are calculating acceleration or deceleration. You need to minus 1 tick when you calculate acceleration. Alright. So here minus 1 tick here. Like here. Here. Minus 1 tick. So when you calculate the acceleration. Okay. Now why? Why? Jigu, I don't get it. Okay, never mind. So we try to see why it is you need to minus 1 tick. So now the reason why it is because of when you calculate acceleration, they are taking half from here. So they are calculating here 1, 2, 3, 4, 5. When you calculate acceleration only, they take from the first half. So here 1, 2, 3, 4, 5, 6, 7. Okay, but to be easy, we just minus them. But teacher, why have to take half? Oh, okay, why have to take half? Huh? Now I show you. Now we are going to calculate how long is this, how long is this, how long is this, and how long this is this. So the longest one is first term T1, it is 0.5 cm. T2 I don't know. T3 I don't know. T2, T3, T4, T5, T6. T6 is 1.4. So how are you going to calculate? Okay, so normally you calculate at Cikgu easy lah. 1.4 minus 0.5. 1.4 minus 0.5. And divided by 1, 2, 3, 4, 5, 6 divided by 6. Okay, we try. 1.4 minus 0.5. 1.4 minus 0.5 equal divided by 6. So everyone had to plus 0.15. Meaning that here is you have to plus 0.5 plus 0.15. 0.5 plus 0.15. So the second term it is 0.65. So this one have to plus 0.15 again. Plus 0.15. You get 0.8. And then next one 0.95. Next one 1.1. What please show what? Please show what? I don't understand what please show you need to tell me show what? Show this? I'm showing. So next one 1.25. It is one, the sixth term it is one, not 1.4. So this is wrong. Huh? What? What? What's that? Huh? Show my feet. What is that? Okay. Okay, this is wrong, right? Okay, never mind. I try to do another one. This one is wrong, So T1, T2. Nó xuất hiện人来搞鬼啊！你看。Okay, the first term it is 0.5. Alright, 0.5. Huh? So the first one and the last one is 1.4 minus 1.4 minus 0.5 equal to 0.9. So 1, 2, 3, 4, 5, 6. I don't want to divide by 6. I minus one group. Minus one group divide by 5. So divide by 5. Okay, divide by 5. So each one have to plus 0.18. So plus 0.18. So 0.5 plus 0.18. How much it is? So the next one equivalent to 0.68. So the next one, I want to plus 0.18 again. At 6. 0.86. So next one, I plus 0.18 again. 1.04. Plus again, I just press equal. 1.22. Plus again, 1.4. So this one is the correct one. So that's why I need to minus 1, minus 1. So it is, they find the difference from here. Do you get what I mean here? Hmm? Okay. All right. Is that okay? So when calculate acceleration only, minus 1 group, minus 1 tick. So if you are doing teacher, this one you don't minus all. 1, 2, 3, 4, 5, you don't minus. Yeah, because we are doing speed. We are doing velocity, we are doing speed. No. Okay? We don't that one. Okay. Alright. I hope you understand it. Wait, I remove that one. Wait, give me 1 minute. Remove. Okay. Alright. So we are going to see this kind of question. We are going to see this kind of question. Oh, never mind. I let you rest for a little while. I want you to try to do some question from here. Page a lot, page 9. Later we are going to discuss. Page 9. Ayo, this one can. Page 9 until page 15, right? You do it on your own right now. We are going to rest for like 5 to 10 minutes as I promised you. 5 to 10 minutes. We are going to continue after 5 to 10 minutes. All right. So you try to do this. If you don't go to toilet, you don't rest for a little while, or after you rest for a while, you can go to try to do this question. All right. I'll be right back. So we continue from here. Okay, remember when you calculate velocity, no need to minus 1. Right? When you calculate acceleration, you need to minus 1. Minus 1 tick. But if the ticker tape is collected, like for example, I got this kind of ticker tape. So I got a lot of tick here. So now when I collect, I can collect it into a group like, for example, I can collect it like 1, 2, 3, 4 tick together, or 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 tick together. Normally we are going to collect it as 10 tick together. 10 tick. 1, 2, 3, 4, 5, 6, 10 tick. For example, 10 tick lah. I don't calculate. We can collect it like 10 tick together. So in this long ticker tape is collected in the experiment. The ticker tape can be divided into small strip with equal number of ticks. So these ticks are cut and attached side by side by the piece of graph paper to show you the chart here. So if the chart is same, so we call it as constant velocity, or we call it as uniform velocity. So this one we can call uniform velocity, or we can call it a constant velocity. Constant velocity also called zero acceleration. I will tell you in the future, not today. Alright, so also called zero acceleration. So when this one it is going getting longer and longer, mean this one is faster, getting faster and faster. So we can call it as uniform acceleration. So this one it is going down like that. So we can call it as uniform deceleration. Or we call it a constant deceleration also can. Alright. Alright. So for example, we look at this example. The diagram shows the ticker tape collected in the experiment to find out the acceleration of the trolley. So the ticker tape is cut every 10 ticks. So here is 10 tick. I calculate for you already. Here also 10 tick, 10 tick, 10 tick, 10 tick. And stick to the graph paper and then give the ticker timer, given the ticker timer vibrate at the 50 Hertz. So if they don't tell you this is 50 Hertz, so you also need to know it is 50 Hertz. Alright, the frequency 50 Hertz. So first one, they ask you initial velocity. So initial velocity is here. Final velocity is here. Alright, so we calculate the initial velocity first. Initial velocity U. U is how long it is. So it is 2 cm. The length is 2 cm. Over the time it is 10 tick here. So every tick you need to multiply by 0.02. 1 tick 0.02. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you don't calculate velocity, no need to minus 1, no need to worry. Okay. Now what do we have is 2 divided by 10 divided by 0.02. So how much will you get? You get 10. So you get 10. Initial velocity, I calculate it. So now I want to find the final velocity. Final velocity is here. Alright. So final velocity is V. V is displacement over time. So I want to know how long is how long it is. So this one it is 10 cm. Alright, this one is 10 cm. 10 cm divided by 10 tick. Multiply by 0.02. 1 tick is 0.02. Okay, so 10 divided by 10 divided by 0.02. 10 divided by 10 divided by 0.02. So how much do I get? I get 50. I'll get 50. Okay, so I got U, I got V already. Now I want to find the acceleration. So how to find the acceleration? So A is equal to V minus U over T, right? A is V minus U over T. So I want to find the acceleration. So V, I got a V just now, 50. U is 10, right? 50 minus 10. Over the time taken. Time taken is, now you need to be very, very careful here because of this one is given in the group. So 1, 2, 3, 4, 5 group. So 5 group, you use 4 group. Every group got 10 ticks. Okay, this is what we have. So 40 divided by 4 divided by 10 divided by 0.02, you will get 50. 50 cm s negative 2. So now, of course, you ask me, teacher, this one is 10 tick, 20, 30, 40, 50. Isn't it? This one is 49 times 0.02? No. You have to minus one group. Here, you have to minus one group. Huh? Here, teacher, here you minus one tick. Yes. Because the distance they gave, it is one tick. If you give me one group, then I have to minus one group. If you give me one group, then I minus one group. If you give me one tick, the distance, then we minus one tick. So this one, we minus one tick only. This one, we minus one group. I'm sorry. 1, 2, 3, 4, 5. So we use 4 only. Okay. Now, acceleration already. Total distance move. So total distance move, as I told you just now, this ticker tape is collected from the trolley when the trolley is moving, right? So the trolley is moving this way. You collect here, you stick to here. Here, you collect, and then you stick to here, 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 here. Right? So now this one, you take all up. You take all of this out. And then stick back to here, you will get back to this ticker tape. So this is how far do you move together. So total distance move. In this case, distance and displacement, it is the same because of the object move in one direction. It is not moving backward. The trolley is moving forward only. So now, how far do you move? 2, 4, 6, 8, 10. So distance move is 2 cm plus 4 cm plus 6 cm plus 8 cm plus 10 cm. So altogether will be 10, 20, 30. Right? It is moving 30 cm altogether. Now, here they're asking you find the average velocity. So how to find the velocity? Velocity is total distance over the total time. Velocity, it is total distance over the total time. Total distance that you have moved is 30. Total time here 10, 20, 30, 40, 50 ticks, right? So 5 times 10 times 0.02. Now, of course, you ask me, Cikgu, this one you don't minus, eh? Just now here you minus. Yeah, when we calculate acceleration, we minus one group. So this one, we don't minus. Okay, we don't minus. Okay, so what we have is 30 divided by 10 divided by 5 divided by 0.02. So I'll get 30. So velocity is equals to 30 cm s minus 1. Minus 1. Velocity minus 1. Acceleration minus 2. Right? Velocity ms minus 1. Are you okay with here? Right? If okay, so we continue from here. Right? We look at the next example. The next example, you see the length getting shorter. So what is this? So you are getting slower and slower and slower. So what is this motion? This is called deceleration. So it is called constant deceleration because of it minus 2, minus 2, minus 2, minus 2, and so on. Right? Alright. Calculate the initial velocity. So first one, initial velocity, u. Distance over the time. Distance is 20 cm. Over the time is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No need to calculate. It is must be 10 one. So in normally it will not give you alang like 8 ticks, 9 ticks like that. No. Normally no lah. Like why teacher why cannot like giving you like nine piece. Oh, for example, I want to calculate this is your hair. Alright, a lot of hair. I cut your hair. I want to calculate how many pieces. So when you want to calculate, you will put 10 together, 10 together, 10 together. Oh, 30. Right? You will not like 9 together, 9 together, 9 or 27 like that. No. What is the purpose of putting 9? So like even harder to calculate. Alright, so you normally it is 10, but cannot be like 100% cannot lah, but seldom to happen. So this one is 10 tick, so 0.02 times 10 tick. So you will get 100. Alright, you will get 100. Okay, after that you need to calculate this, right? Need to calculate this. This is final velocity. V is equals to distance over the time. So the distance is here, it is 12. This is 2018, 16, 14. This is 12. Alright, nothing wrong. 12 divided by 10 tick times 0.02. So 12 divided by 10 divided by 0.02. I will get 60. 12 divided by 10 divided by 0.02. Yeah, I'll get 60. Right, I'll get 60. Yeah, correct. All right. So after that, so we are going to calculate acceleration. So number 3, acceleration. So acceleration is A is equal to V minus U over T. Right? Acceleration, I don't know. Acceleration, I don't know. V, final velocity, I got it from here, 60. Minus initial velocity, 100. Over the time taken. So 1 group, 2 group, 3, 4, 5 group. So 5 group, I use 4 group because I am calculating acceleration. So 4 group, each one is 0.02 times 10. Okay, so how much will I get? 60 minus 100 equal divided by 4 divided by 0.02 divided by 10. So I'll get negative 50. Okay, the unit is CMS -2, right? -50. If you ask me what is the acceleration, -50. If you ask me what is deceleration, 50 CMS -2. All right. I hope you understand. -1 group don't forget total distance move. So you plus this one up, right? Distance move is 20 plus 18 plus 16 plus 14 plus 12, right? So how much is this? 20, 30, 40, 50, 60. Add plus 2 is 60, 70, 20, 40, 50, 60, 70, 6 plus 4, 70, 80, right? Altogether 80, right? 80, right? The distance move is 80. So average velocity, how to calculate the average velocity? Velocity is distance or displacement over the time, right? Displacement is at t. Over the time, 1, 2, 3, 4, 5, you don't need to minus, right? 5 times 0 0.02 times 10. Okay. Okay. At t divided by at t divided by 0.02 divided by 10 divided by 5. Alright. So I'll get at t also. Unit is CMS -2. CMS -1, I'm sorry. Alright, I hope you understand this. Okay. Alright, so this one, question number 8 is your homework. Right, you try to do it. Not question. Example homework. Page 8, example 19. Alright. One question. You do it later. After that, you send it to me. I'll mark for you. Right? You do after the class. Alright, so today we are going to continue to do here. Alright. Now, Kedah 2022, 2022, yeah, correct. So, diagram 2 shows the movement of the car from stationary. Here it is stationary in 5 seconds. Right? Which one is correct to describe the movement of the car? So, here, not moving, rest. Stationary, yeah. So, here, start to move. So, this one you accelerate. Normally, you are going to take, if this one is moving, so from the time 0, 1, 2, 3, 4, 5, so this one is like 20, 20, 20, 20. This one is moving with constant velocity. But this one is not. This one is not. Why? Because here it is rest. Right? Initial velocity is 0. This one final velocity, I don't know. Right? But you are moving already. You're moving 20 already. So here got velocity. Right? Let's say it is 1. So A is equal to V minus U over T. V is got value. So you got acceleration. Here got acceleration. Here don't have. Why? Because of constant velocity. So you are moving 20, 20, 20, 20. So here it is constant velocity. Here it is acceleration. You got an acceleration. So now acceleration OA is greater than AB. OA is greater than AB. Yeah. Constant velocity, acceleration is 0. Right? Constant velocity, acceleration is 0. So the acceleration is 0. Here got acceleration. So answer it is A. Okay. Now we continue to do more question. It are Ifan, I don't know how to pronounce this. Ifan will pass in front of the supermarket in 60 meter and then 80 meter here to the playground. All right. So what is a displacement? So displacement is where do you start to where do it stop? 60, 80, 100. So answer is 100. If distance, you have to plus them. Displacement, just where do you start and where do you stop? How to find the displacement? Open your eye, see where am I, close your eye, and then move, finish moving, open your eye, see where am I. So it is here. So it is where here to here. Use Pythagoras theorem, you get answer as C, 6 at 10. Okay, a car starts to move from rest and take 8 seconds to move to the velocity 5. Calculate the acceleration. So how to calculate here? A is equal to V minus U over T. So you are going to put in the information. A, I don't know. V, final velocity. So to reach a velocity at from rest, 50 minus 0. From rest, initial, it is 0. This is final velocity. This is time at second. You look at the unit. 50 divided at, you will get 50 divided by 8, you will get 6.25. Unit is ms negative 2. So answer is B. All right. So, diagram 2 shows a ticker tape chart for the motion of the trolley. So this one go same. So we called it as constant velocity. Okay, constant velocity. Go up, acceleration. Go down, deceleration. So Lamri takes 30 minutes to cycle through PQR. P to Q to R. Alright. 4 km, 3 km, and here. So what is the speed of the Lamri cycle from P to R? So speed is distance over time. Right? Speed is distance over time. Distance. So you need to plus them up. You can see how I move and then you plus them up. So how much is the speed here? 4,000 and 3,000. So 4,000 plus 3,000. Over the time taken. Time taken is 30 minutes. 30 minutes. So you need to multiply 60 to change it to second. Okay. 7,000 divided by 7,000 divided by 30 divided by 60. So altogether I will 3.89. So answer is 3.89. Unit is ms negative 1. So we got 3.89 ms negative 1. So answer is A. Alright. So which of the following is true regarding to the motion of car? Constant velocity. Constant velocity, zero acceleration. Alright. I just tell you, I will teach you maybe 2 more lessons after this. Right? I will tell you when I am teaching this part. Linear motion graph. Alright. Here. When I'm teaching here. Alright, what zero acceleration or what? Okay, not today. Okay, this kind of question, motion graph with chart 1, I haven't teach you yet, so I will skip this kind of question. So we continue with here. Diagram 2 shows a thicker tape strip which are cut and attached side by side. So which is the type of motion? So this one is going down. So uniform velocity, no. Uniform velocity, it is same length. Increasing velocity should be going up, no. Non-uniform velocity, velocity decrease uniformly, yes. Excuse me. When the object travels with constant velocity, acceleration 0. Okay, acceleration 0. Diagram 1 shows a linear motion graph of the moving object. Which of the following segment it is correct to interpret the graph? The graph I haven't teach yet. The motion graph, so I skip this question. Alright. Okay. This question I also need to skip first. Right? Graph 1 I skip first. So next one. Diagram 1.1 shows the trolley moving downward an inclined plane. The ticker timer vibrate at the frequency of 50 Hertz. Okay, what is the meaning of the displacement? So what is displacement? Displacement is the distance moved into a specific direction. Right? So now it has a direction. So it is the distance that you have moved, right? But got direction one into a specific direction. Tick the correct answer in the box. Okay. So now what kind of this? This is an alternating current. Right? This is an alternating current. Not direct current, alternating current. Okay. Now, 1.2 shows a ticker tape produced by the motion of the trolley. So calculate the time taken for the movement of the trolley from X to Y. So time taken is 1 tick, 2, 3, 4, 5, 6, 7 tick. Alright. 1 tick is 0.02. So 7 tick is 7 times 0.02. So answer is 0.14 second. Okay. Name the motion of the trolley. So the direction of the motion, it is here. So you move from here. Here it is short, slow. Right? Here it is fast. So this one is called acceleration. If you move from here, then this one fast becomes slow. So fast becomes slow, it is deceleration. So this one is called acceleration. Okay. Diagram 11.1 and 11.2 shows the two ticker tapes with different length to produce motion of two trolleys. Alright, set the type of the physical quantity of length. So physical quantity of length is best quantity. We learned last chapter already. Or a vector of scalar. Alright, this one it is length, it is vector of scalar, should be scalar. Okay. Now, referring to 11.1, 11.2, compare the number of tick here. Compare number of tick. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, this is number of tick. Number of the ticks in diagram 11.1 is same as number of tick in 11.2, right? Same. The next question, what are they asking you? Compare the length of the ticker tape and compare the average velocity. So compare the ticker tape, which one is longer? 11.2. So the length of the ticker tape in diagram 11.2 greater than 11.2 more than 11.1. You can write into this way or not? Can. So if you want to write in full, also can. You can write the length of the ticker taps in diagram 11.2 is greater or longer than 11.1. Okay, one. So next one, what are they asking you? Compare the average velocity. Here it is fast, here it is slow. So average velocity in diagram 11.2 greater than 11.1. Okay. Next one. Next, state the relationship between distance between the consecutive point and the type of the motion of the object. So this is 5 mark. 1, 2, 3 already. 2 more mark from here. Set a relationship between distance between consecutive point. Okay. So what is distance between two consecutive point mean? So this point, this point, this point. Distance between two consecutive point is here. Distance between two consecutive point is here. So this one can have many kind of answer. Alright. So I can say the greater the distance between two consecutive point, the faster the type of motion, the greater the velocity of the object. The greater the distance between two consecutive points, the greater the velocity of the trolley, of the object. Alright, this one they said object, then I move up. I said object lah. Okay, is that okay? We try to have a look into the answer. Terengganu 2021. Terengganu. Question 11. So this is best quantity or scalar quantity, up to you. You want to write best quantity or scalar quantity, up to you. Now B is the first one. The number of tick both sides are the same. Okay. The length of the ticker tape in 11.2 is greater than 11.1, or vice versa. So what is vice versa mean? Vice versa mean you can write terbalik. What is mean by write terbalik, Lee? So you can write the length of the ticker tape in 11.1 less than 11.2, right? Less than 11.1. 11.1 less than 11.2 also can, right? Vice versa. Okay. Average speed at the 11.1 greater than 11.2. Average velocity 11.2 more than 11.1. Yeah. 11.2 more than 11.1. Yeah. So now, as the length of the ticker tape increase or decrease, the speed increase. As the longer the ticker tape, the further the distance, the average speed increase. If you said decrease, so this one decrease. So when the distance between two consecutive points are the same, the object move with constant velocity. That's why I got 5 marks. So I short of 1 mark. Right? So yeah. So one more. Okay, when the when the point, the distance all the same, mean the object is moving with constant velocity. Is that alright? Okay, so we try to do one more. Continue from here. Now, diagram 11.3 shows the pattern of the oil drop from the car, uniform red on the rod from the moving car. Explain the type of the motion occur at the beginning and the final of the car, motion of the car. So now this car, it is from here. The pipe of the oil here leak. So it drip down. Tip. So when it is moving, this car is moving from here to here. So it will drip to here. So here to here. So here he move fast. So the distance of the drip, it is far. Right? Distance of the point, it is far. Right? So here it doesn't really move. It moves slow. So it drip very slow. Not the oil drip down with the same rate, same speed, but just the car move with fast or slow only. So we are knowing that here it is fast, here it is slow. Slower. Okay, explain what motion of the car. So and the final motion of the car. Beginning type of the motion, it is here. You see, what do you see here? It is the distance all the same. Right? Here, suddenly become deceleration. So, beginning, it is constant. So, what happened is the car is moving with constant velocity with higher fast. It is moving fast because the distance is far, right? Here it is moving with constant velocity with moving fast with constant velocity. Moving fast with constant velocity. Yeah. Okay. Now at the end, the final motion of the car, it is here, deceleration. Right? So you need to explain, right? Why? You explain here. The car moving with constant velocity, why? Why you are saying it moving with constant velocity? Explain. Because this one is 4 marks. You need to know the number of marks. Where is a mark located? So because the distance of the oil drop, are the same, right? All the distance of the oil drop are the same, right? And why you saying fast? Fast because of, if you want to explain, right? You explain a little bit, right? So the distance of the oil drop is far apart from distance of the consecutive, right? Consecutive oil drop is far apart, right? So it is fast. Okay, I explain both. Next one, at the final motion here. So final motion, the car is decelerating. Right, decelerating. Why you are saying that decelerating? So the distance of the oil drop are getting closer, right, to each other, right? Getting closer and closer and closer, or the distance shorter. You can set distance shorter, no problem. All right, so we see how do they answer. Okay, here at the beginning, the distance consecutive oil drop, it is uniform, all the same. So the car move with the car move with uniform velocity or uniform velocity or uniform speed. All right, uniform speed and same. So the keyword here, same. So what we have is same and then constant velocity. Okay, both are okay. So this one they don't say fast. They don't say here fast, right? Now at the final motion, so the distance between the consecutive oil drop decrease, right? Distance between the oil drop decrease. The car move with deceleration, right? Deceleration. You don't say deceleration speed, just say deceleration. Or velocity decreasing also can, right? So because of the car is decelerating, because of the distance getting closer. So I should not use closer. I should use the decrease. The distance between the consecutive point decrease. Closer. I know it is the same, but don't use the the crosser. Even I know, but I still use it. Should not use. Okay. Is that okay for you? Question? Okay. Now this one we cannot do yet because got angle one. This one belong to form 5 one. Here, I only got one homework for you. Just the question example number 19 just now. You can do it right now and send it to me after this. All right. If you haven't pressed the like button, help me to press the like button. Thank you very much. If you got friend want to join, right, you can forward to your friend. And starting now it is free. February and March, now it is March. March is still free tuition, right? After because some of the parents asking me, right? After March it is not free, but still cheap. I tell you, still cheap. You compare to others, still cheap. All right. So I am 65 only per month, the tuition fee, right? And after this, the link will be not in public already. So I will not send into public already. So it will be only my group can watch only. So if you are not in my group, you cannot watch already. Okay. So join. Now you join, it is free. You can get the notes some more. All right. Okay. Any other question? If no question, I am going to stop here. You help me to press the like button. Thank you very much. So I'll see you next week. Next week we are going to do the formula, linear motion formula. Right, this one. Linear motion equation. Okay? I'll see you. Bye bye.
上了2个小时的课，大家都辛苦了，谢谢你们有专心上课。下个星期一样时间我们再见。